Welcome to General Structures 2 and Lateral Forces, Lesson 3, Example number 2. And should be Part 4, I believe. And we left off, we had just gotten FCDY equals 3.75 kips, and that's in tension. So we need to figure out what FCDX is. And as you can see, FCDX is right here. And there's a couple ways to go about this. You could look at this triangle right here. Let me change colors. Would be a good color to show this. Kind of used all my colors up here. Let's use light blue. You could look at it with this triangle right here, which I'm going to go ahead and do. That's the triangle you're looking at. Is this triangle right there. So you're going to have 10 and 6.8. Or not 6.8, 6.666. 6 foot 8 is half. So that's what the triangle is. Those are what your sides are. So go ahead and get rid of that. So we're looking at this triangle right here. And I'll just go ahead and draw it over here so we don't get confused. Here's the triangle we're looking at. And it's coming out of, this is point C right here. Alright, so our sides to this triangle are 10 and, what did we say, 6.66 foot. So we want to make our similar triangle. And our similar triangle, we say that the y dimension is 3.75. So we can say, okay, 3.75. Now, once again, this is kips. That's in foot. But similar triangles are similar triangles. So you don't really need to. It can confuse you if you try to put the units on. So maybe leave them off. Whatever's good for you, because similar triangles are going to look like that. All right. So, anyways, where were we at? So here's our other one, and this is going to be FCDX. So let's put FCDX on the top. FCDX over what, 3.75 equals 10. No, wait, 6.66 over 10. And if we do 6.6666, lost the 6 divided by 10 times 3.75, and we get 2.50. FCDX equals 2.50, and that's kips, and that's going to be tension since it's positive. And that matches up with this tension, so we know they're both. So we have our components. We need to do a squared b squared equals c squared. And therefore, we need to take 3.75 squared plus 2.5 squared. And the square root of that sum is 4.51, which is FCD. And that's going to be in tension. So that's our answer. FCD equals 4.51. So they both equal the same. But one's in tension, one is in compression. Those are our answers because this lines up with, if you'll remember, this is actually 2, this is 3, and this is 4. And we're looking for 2, 3, which is BC. And if you look in the study guide, let's go ahead and check it. And it says 2, 3 equals negative 4.50, it says, but kips and compression, C. And then we go to F34, which corresponds to our FCD, it equals 4.50, which we said 4.51 kips, and tension. So those are our answers. And if you need to go over and follow this again, that's great. And if you didn't like my similar triangles issue, you can go back. Once again, if you're doing this on calc paper, it's probably 1,000 times easier. But you can go back and you can figure out what these angles are, because we initially figured them out, and use your trig identities to figure out what your, since this will be the same, what your FCDX is and what your other component is, and then you could also figure out what your hypotenuse is from that. So you don't even have to figure out what FCDX is, that's not important. You could take your angle and your adjacent leg and you could figure out what your hypotenuse is. Alright, I know this was very long and a little bit arduous, and I think it says in the beginning of this question, actually I'll read it right out loud, it says Like example number 1, this problem is probably more difficult and time-consuming than any you will encounter on the actual exam. However, if you understand the procedure, you should be able to solve any trust problem on the exam that involves the method of sections. So remember again, this is the method of sections, and the method of sections is when you take the entire truss and you cut it somewhere. You cut it straight line pretty much across. You cannot take a method of sections and cut like that. So that is the method of sections. I hope this was helpful, and I will see you on example number 3.